All right, good morning, everybody. One of the very last things we're going to learn all year, z-scores. The thing about z-scores is it sounds kind of crazy, but you guys understand the concept of z-scores. In fact, I can almost guarantee you've used a z-score argument when you talk to your guardians at home, whether it be mom or dad or grandma or grandpa or aunt or uncle, whoever it is, okay? The z-score is a value that shows how many standard deviations a data value is from the mean If the z-score is positive, the data value is above the mean. If the z-score is negative, the data value is below the mean. And when the z-score is equal to 0, the data value is the mean. So to make this kind of like as simple as possible, okay, your z-score has nothing to do with your actual score. Your z-score is how you compare to everyone else, okay? So what I mean by this is, let's say you get home and, dad's waiting at the door and dad says, hey, man, what the heck's this? You got a 62 on your test? And you're like, Dad, listen, man, I got the best grade in the class. Like, you got to back me up on this. You should be proud of me. I'm the smartest one in the whole class. I know Dad, I know a 62 doesn't look good. But listen, man, everyone failed it. Johnny got a 45, right? That is a z-score argument, okay? What you're doing is you're saying, ignore the 62, compare me to the average, and you'll be impressed because compared to average, I'm above average, okay? So we get a little formula here, and again, it's a formula that makes sense. Your z-score, which we'll just use a z, and I like to use a z with a little slash through the middle because a lot of times it can look like a 2 if we don't do that, is going to be a fraction, right? Our z-score is going to be whatever score you got minus the average. And so that's going to tell you how far away you are from the average, right? If you scored a 60 and the average was a 40, 60 minus 40 would tell you 20, that you did 20 better than average. Then you're going to take that, you're going to divide it by a standard deviation, which will tell you how many standard deviations you were away from the mean, right? So let's look at number 1 here. A radar detector records the speeds of a group of cars that pass by. If the average or if the mean is 46, I'll go ahead and highlight that. That seems like pretty important information here. The average is 46. And the standard deviation is 2.8. Okay. Gotcha. Find the z-scores of each value. Okay. So again, what these are is these are comparing the number itself to the average, right? And so this 52 is above average. This 42 is below average. This 47 is just slightly above average, okay? And so if we just do our little formulas here, okay, what would the z-score be if our value was 52? If our average, let's get a color you guys can actually see. If our average was 46, and if our standard deviation was 2.8. That's it. That's how we find the standard deviation. We got to type this in a calculator. We can use Desmos. You can use a phone calculator. 52 minus 46 divided by 2.8. Cool. Desmos fraction 52 minus 46 over 2.8. That's what it is, right? 52 minus 46 over 2.8. Sure, there we go. So this answer that I've gotten is the z-score, 2.142. You know, we can do 3 decimals. That's fine. Let's use red. 2.143, because I guess we can round, but it's not a huge deal. There we go. That is the z-score. Oh, forgot my C. That is the z-score. Now, just to remind you guys, this z-score value is the same as how many standard deviations you are away from the middle. So you don't need to do this, but this is always an interesting kind of demonstration for students. If we think about our normal curve from yesterday, where the number in the middle, which is 46, and then we need to be adding 2.8 to get our other numbers, right? So that would be 48.8. This one would be 51.6. This value should be the measure of how many standard deviations we are away. Okay, so look, here's 51.6. This value right here would be where 52 is, right? That's where our number 52 is just past middle, where 0, 1, 2, 2.1, right? So this is literally just counting the z-scores. If we wanted to know what the z-score of 51.6 is, the z-score would be 2. Because it's literally on 2 standard deviations away. So luckily, if your number falls perfectly on one of these standard deviation numbers, the z-score is just the standard deviation. So it would be a positive 2. Now, just to make the point, if we're going left, which is where we're going next with 42, 42 is going to be kind of like in this area. And so we can expect 42 to be about -1 and some change, right? Because it's not going to be at that -1. It's not going to be quite to that -2. It's going to be in between there somewhere, okay? So you don't need these charts. Oh, sorry. You don't need these charts to do the z-score stuff, but it's very much related to these charts. Anyways, let's knock this out. Let's do these pretty quick. Let's just do one. Let's just do B. We'll skip C. B is equal to 42 minus 46. Color sucks. Minus 46 divided by 2.8. Literally, if you're on Desmos, all you need to do is change that 52 to a 42. And it's exactly what we thought, right? -1 and some change. -1.429 if we round it. Sure. -1.429. And that would be our z-score. Now, not always do we need to just calculate the z-score, because this is a really simple formula, but sometimes they'll tell us like the z-score and they'll be missing the mean. And so we'll have to use the formula to solve for the mean. So we'll see that in 3 different questions here, and then we're done with the notes. The mean number of total miles ran last week by each player on the track was 4. So I'm just going to go ahead and make a little list here. We know that the mean was 4. We know that the standard deviation was 1.2. And we know that the z-score was 2.5. How many miles did he run? So we actually don't know in this question here how much Clay actually ran. We know the average, we know the standard deviation, and we know how he compared to the average, but we don't know how many miles it was he ran. So we do the same formula, but we need to plug the stuff in. So here's the formula where it's kind of empty. And then to plug the stuff in, we know that it should be 2.5 is equal to -4 over 1.2. But we don't know what his actual X value was. We don't know what his actual miles ran was. So what we're going to do is we're just going to leave this as the X, and now we're going to solve for that X. Okay, so we're going to need to multiply by 1.2 in order to get rid of this 1.2 on the bottom. So we need to do 1.2 times 2.5, which looks like it's going to be 3. So that would put us at 3 is equal to x minus 4. And then we need to solve for this. So we would need to, I mean, you guys know what you're doing here. Add 4, add 4. And so we would get x equals 7. Now, again, you might have a teacher or a test that's going to be super specific. Technically, maybe the better answer is 7 miles because, you know, we're talking about how many miles did he run. He's run 7 miles. But again, this makes sense, right? I mean, if the average was 4, standard deviation was 1.2, and he ran 2.5 standard deviations above. That would be starting at 4. 1 standard deviation would be 5.2. 2 standard deviations would be 6.4. And then half a standard deviation would be adding 0.6, and that will get you up exactly to 7. So we could have almost done this one in our head because the numbers were kind of nice. At the end of the day, he's running 7 miles. We are going to do all 3 of these because they're going to give us all different looks now. When it comes to number 4, we know that we have a standard deviation of 5. We know that they scored an 83 and that they had a z-score of negative 0.4. And what we're missing is what was the average. And so again, just kind of using our context clues a little bit and thinking just for a second, if 85 was their score and their z-score is a negative number, then that means they did a little bit less than the average, right? So we can guess that the average should be somewhere in the 84, 85, 86 range, right? Just a little bit better than what we saw. Okay, we do the formula here and we have the z-score of negative 0.4 is equal to fraction 83, 5 on the bottom, and then we don't know that mu value. We don't know that average value. We need to solve for this. So we need to, multiply by 5, multiply by 5. 5 times 0.4 is going to be 2. Because I'm thinking 5 times 4 is 20, but we have a decimal place there. Let's keep going. So that's going to be negative 2 is equal to 83 minus mu. There's a couple different ways you could decide to solve for this. What I would probably do is I'd probably just add the mu to the other side so that I'd have mu minus 2 equals 83, and then add the 2 as a next step, plus 2, plus 2. And so our prediction was pretty good. Okay, our average is 85, right in the ballpark of what we were anticipating seeing there. And, basically what's going on here is that in these questions we were missing our z-score. In these questions we were missing our value. In this question we were missing our mean. And so down here we're going to be missing our standard deviation just to kind of give us the world tour of everything that we might have or might be missing. The average is 14.3. The z-score for a 20-foot tall tree is 1.9. So we got to be a little careful here. The z-score is not 20. The z-score for a 20-foot tall tree is 1.9. And then we have the tree itself, which is going to be 20 foot tall. Now, to bring this back, just for 2 seconds, if we go back to our normal curve, and I'll draw a normal one because that one kind of got butchered up there. If we draw another normal curve, remember that your normal curve has 1, 2, 3, -1. Oh, that's not a very good line. -1, -2, -3. It's got 3 lines on each side, which means your z-score is either going to be -1, -2, -3, or maybe -4. But you'd have to be extremely, should be +1, +2, +3, +4. Would have to be extremely above average to be over here, right? Over this direction, it would be -1, -2, -3, or -4. Maybe -4. You'd have to be extremely below average to be -4. In the middle would be 0. No way can you have a z-score of 20, right? Z-scores pretty much have to stay between -4 and +4. So if you ever get a z-score that's like 7, I mean, that would be a data value that is literally like over here on the normal curve. Like, that's not really how that stuff works. So just wanted to chat about that for just a second. Of course, what are we missing? Standard deviation. We don't know what that is. So let's do our formula here. The z-score of 1.9 is equal to our value of 20 minus 14.3, all divided by standard deviation. Now, this is always the hardest one for students when you have variables in the denominator. The best way to get a variable out of the denominator is to just multiply it on both sides. And so when you do that, you know, these two will get crossed out. It will appear on the other side, and then you're pretty much ready to roll. So didn't mean to do that. So rewriting this a little bit, we've got 1.9, I guess I'll use blue, times percentage deviation is equal to 20 minus 14.3 would be 5.7. And then we need to do some division here. Obviously, divide by 1.9, divide by 1.9. And we're going to get 5.7 divided by 1.93. All right, cool. Looks like our standard deviation is 3. That is z-scores. That's all there is to it. When it comes to z-scores, again, it's a value of how many standard deviations you are away from the mean. Okay, it's comparing your score to the average. Your score is basically stuck between -4 and +4 as far as your z-score goes. Remember that a positive z-score means you're above average, a negative means you're below average. If you ever see a z-score of 0, you are the average. Okay, there's no difference between you and the average. That's it, though. We're done with notes. Getting very near to the end of the year. So hope you guys are excited about that.